to example 9. Again, we want to sketch the curve y, so we'll follow the steps. In step 1, we will find the y-intercept by letting x equal to 0. Then the value of y would be 3 over minus 1 times minus 3. So it gives us the value 1. So when x equal to 0, y is 1. So 0, 1 is a point on the curve. Step 2. We want to know what happens when x goes to plus or minus infinity. So when x goes to plus infinity, let's see what happens to y. Y is going to be 3 over, well, a very large number minus 1 is a very large number. So just write infinity there. A very large number minus 3 is still a very large number. So y goes to 0. When x goes to minus infinity, y would be 3 divided by minus infinity minus 1 is still a very large number, which is minus, times minus infinity minus 3 is again a very large number, which is a minus, so goes to 0. As a number divided by a very large number is 0, so y goes to 0. So when x approaches positive infinity, y goes to 0. When x approaches minus infinity, y goes to 0 as well. And the value of y would be slightly positive, because you have, when x goes to positive infinity, you have a positive number in the numerator and a positive number in the denominator, a very large number. Same thing here, when x goes to minus infinity, we have a positive number in the numerator and also a very large positive number in the denominator. So in both cases, y will be slightly positive. Okay, now step 3. We want to determine the stationary points. So we need to differentiate y. So y is 3 over x minus 1 times x minus 3. Now, to differentiate, we need not expand the brackets out, but let me do it in this way. But you can try differentiate without expanding the brackets in the denominator. So dy dx is a term in the denominator times the derivative of the numerator, which is derivative of the numerator is 0. So minus the term in the numerator times the derivative of the denominator. So derivative of x squared is 2x, minus the derivative of 4x is 4. So we have minus 4 over the denominator squared. So when the derivative becomes 0, so when dy dx equal to 0, if we set dy dx equal to 0, we have the numerator equal to 0. So you got 2x minus 4 equal to 0, which implies x must be 2. So at x equal to 2, we have a stationary point. And when x equal to 2, what is the value of y? We have 3 over 2 minus 1. So let's determine the value of y. We have 3 over 2 minus 1, and we also have 2 minus 3. So the value of y is minus 1. So there is a stationary point at 2 minus 1. So let's determine the nature of the stationary point. So let's put the value of x underneath and dy dx above, and there is a stationary point at x equal to 2. So if we pick a number less than 2, for instance 0, what is the value of dy dx? So the dy dx will have a positive numerator when x equal to 0. When x equal to 0, it will have a positive denominator, so dy dx is positive for values of x less than 2. At 2, dy dx is 0, we've established that. And for values of x greater than 2, for instance, let's take 2.5. So the value in the numerator, if it's 2.5, if x is 2.5, we can see we have 5 minus 4, so that's a positive number, multiplied by a negative number gives us a negative number in the numerator. In the denominator we have some number squared, so it's positive. So negative over positive is a negative number. So for values of x greater than 2, the derivative is negative. So we have a positive gradient. For values of x less than 2, at 2 we have a 0 gradient. For x values greater than 2, we have a negative gradient. So clearly at x equal to 2, it's a maximum. So the curve should look something like that. Now you can check for points of inflection by checking the second derivative of y, which is left as an exercise for you to do. And if we do that, we will find that there are no points of inflection, no values of x that makes the second derivative equal to 0. Now step 4, in fact we exchanged step 3 and 4, but that doesn't matter. We need to find the asymptotes of the curve. So asymptotes are values when y becomes undefined. So clearly looking at this expression for y, in the denominator we have x minus 1 and x minus 3. So when x equal to 1 and x equal to 3, y is undefined. So x equal to 1 is an asymptote,